Let's do a problem from your lab assignment, section 11.4. This is problem number 1. Determine whether the series converges or diverges. Series is n goes from 1 to infinity of 7 times sine 3 over n. So it looks like their approach here is going to be the limit comparison test. So just to backtrack and take a look at what the limit comparison test is. Suppose that you have a couple of series with positive terms, and if you take the ratio of two series and the outcome is equal to c, the limit is equal to c, where c is some finite number, then both series do the same thing. Either they both converge or they both diverge. So that's the limit comparison test. So using the limit comparison test, what we're going to do is we're going to compare this with 1 over n, or in this case 21 over n. Now how did they get 21 over n? This thing has a 1 over n, and kind of looking ahead, if you take a look at the ratio between sine of something over something, it's as x goes to 0, it approaches 1, so it's something finite. So it's something to be able to compare to. So the term 21 over n, this the series here, it's all positive, and since for n is equal to positive, some positive values, 3 over n, the thing that goes inside of the sign, is always between 0 and pi, and sine is going to be positive between 0 and pi. So that they're all positive terms. And that satisfies our criteria for the limit comparison test. And keep in mind that the series 21 over n is like a harmonic series. It's 1 over n, or you can think about it as a p series. And it's important for us to remember that it diverges. So now limit comparison test says we put a ratio of those two different series. They put the 21 over n, so the 7's cancel already. And then now, as if we substitute m going off to infinity, as n goes off to infinity, then this denominator goes to 0, and then a number over 0 is going to be, this denominator is going to go to infinity, and then a number over infinity is going to approach 0. So we can change that as m goes to 0. And this was a popular limit that we had. You can either use L'Hopital's rule here, or remember that the limit is equal to 1. Actually, using L'Hopital's rule would be good. So the derivative of sine is cosine m. The derivative of m is 1 with respect to m. So cosine of 0 is 1 divided by 1. It's going to be 1. So that's a quick way of thinking about it. And so now this number is a finite number that's bigger than 0. And so both series are going to do the same thing. And since we've seen that the series 1 over n diverges, that's going to have us conclude that the series with the sign is also going to diverge. So this is divergent. All right, hope that helps.